Here I have drawn the triangle ABC, which is formed by the intersection of the three lines, that is line 1, line 2, and line 3. And I have marked the vertices as A, B, and C, where A is the intersection point between the lines L1 and L2, and B is the intersection point between the lines L2 and L3, and C is the intersection point between the lines L1 and L3. So basically, the intersection points is nothing but the vertex of the triangle. So once we determine the three vertices of the triangle, we then find the side length by using the distance formula. So once we find the side length, we can determine the perimeter of the triangle. That is, the perimeter of the triangle is AB, the side length AB plus the side length BC plus the side length AC. So this is how we have to determine the perimeter. So our first task is to determine the intersection points. That is, we have to find the vertices of the triangle. So let's see how to find the intersection point A. So for this, we have to consider the lines L1 and L2. So I'm going to first write down the parametric equations of line L1 and L2. So first, let me copy the line 1, that is x, y, z, and this equals 1 comma 2 comma 3 plus t times of 2 comma 0 comma 4. So this is line 1. I'm going to write down this parametric equation of line 1. So this means x equals 1 plus 2t. So I write down x equals 1 plus 2t and y equals 2 plus 0t. So this equals y equals 0 plus I'm sorry, it is 2 plus 0t. So I'm going to change this to 2 plus 0t. And finally, this z equals 3 plus 4t. So I write down z equals 3 plus 4t. So this is the equations which represents the line 1. This is the parametric equation. Now similarly, we will write down the parametric equation for line 2. So first let me copy the line 2. This is line 2 is x, y, z, and this equals negative 1, comma 2, comma negative 1 plus s times of 6, 1, negative 1. So I'm going to write down the parametric equation of line 2 over here. So I write down x, that is this x equals negative 1 plus 6s. So I write down negative 1 plus 6s. Then y, this equals 2 plus 1s. So maybe I write down in the same color. It is y this equals 2 plus 1s. This is 2 plus 1s. And finally this z, this equals negative 1 plus negative s. So it is negative 1, negative s. Now let's see how to determine the intersection point. So line 1 and line 2 intersect, the corresponding coordinates will be same. That is, this x will be equivalent to the x of the line 2, and the y in line 1 will be the y coordinate of line 2. So first, using these two equations, we will determine the values of s and t. So when we use the line 1, the x coordinate of line 1 equals 1 plus 2t. So therefore we can, maybe I could just write down over here itself. I'm going to write down here. So this is 1 plus 2t. This equals the x coordinate of line 2 is negative 1 plus 6s. So I'm going to write down this as 2t minus 6s. This equals negative 1 is negative 2. This could be simplified when I divide this by 2. So therefore this becomes t minus 3s. This equals negative 1. So let's say this is equation 1. Now using another equation, that is the y coordinate equation, we have y equals 2 plus 0 t. That is, y is basically 2. And here we have y equals 2 plus 1s, which is 2 plus s. So therefore, when we equate these two, we will get 2 equals 2 plus s. and this implies s has to be 0 because we cancel this, and this implies s equal to 0. So we determine the value of s. Using this value of s, we can plug it into the equation 1 to determine the value of t. So let's do that. So I'm going to plug in s equal to 0. So therefore this becomes, that is equation 1 becomes t minus of 3 times of 0. This equals negative 1. This is 0, and this implies t equals negative 1. So we determine the values of t and s. Now we have to check if these two values are consistent. For that, we take the value of s and t and substitute in both equations of z. So let's do that. I'm going to substitute t equals negative 1 into the z of L1. So therefore this becomes 3 plus 4 times of t is negative 1, and this becomes 3 minus 4 is negative 1. So here we get the value of z equal to negative 1, and when I substitute s equal to 0 into the z equation of L2, I get z equals negative 1, negative 0, and this equals, we are getting z equals negative 1. So clearly these two values of z are consistent, that is they are exactly the same. We are getting the same values of z whether we substitute s or t into the z equation, which means the values of t and s which we found are correct. So now we can easily determine the coordinates x, y. We already determined z, which is equal to minus 1, by substituting in any one of the equation. That is, we substitute the value of t into the x or y equation of L1, or we substitute the value of z into the x or y equation of L2. So I'm going to substitute in the line 1 equation. That is, I'm going to take the value of t equals negative 1 and substitute into the line 1 equation. So we have x equals 1 plus 2 times of t. That is 2 times of negative 1. This becomes 1 minus 2 equals negative 1. So we found the value of x equals negative 1, and y is already, that is 2 plus 0t. So that is y equals 2. So we determine the value of x equal to negative 1, y equal to 2, and z equal to negative 1. So we put the intersection point. This is, we are finding the intersection point A. So we can now see that the intersection point A, or the vertex A of the triangle, is x comma y comma z. That is x equals uh, negative 1 comma y equals 2, and z equals negative 1. So this is the intersection point A. So here I have marked this vertex A as negative 1 comma 2 comma negative 1. Now let's see how to determine this intersection point B, or the vertex B. For that, we have to consider the parametric equations of line 2 and line 3. So first let me write the parametric equations of line 2. That is x equals negative 1 plus 6s. So x equals negative 1 plus 6s, and y equals 2 plus 1s. That is 2 plus s, and z equals negative 1, negative 1 times of s. So negative 1, negative s. So this is the parametric equations of line 2. And for line 3, we are already given the parametric equations. So I'm going to write down over here. That is x equals 5 plus 4p, y equals 3 plus p, and z equals negative 2, negative 5p. Now we will follow the similar way of finding the x, y, and z. So first we equate the x to x of line 2 and line 3, and y to y of line 2 and line 3. From that we determine the value of s and p, and then substitute the s and p into the z so that it is consistent. Once we determine the it is consistent, we can back substitute the values of s and p into either the equation of L2 or L3 so that we determine the coordinates. So let's start to do that. I'm going to equate the parametric equations of the x coordinate between L2 and L3. So therefore this becomes in L2 it is negative 1 plus 6s. This represents equation x, and 5 plus 4p is represented by x in L3. So now we can form an equation between s and p. So therefore this is 6s minus 4p, and this equals, we can add 1 to both sides. So this becomes 5 plus 1 is 6. I'm going to write down this in simplified form by dividing all the terms by 2. When I do that, I get 3s minus 2p, and this equals 3. So let's have this equation. And now I'm going to equate this y coordinates equation, that is the parametric equations for y. So when I do that, I get 2 plus s, and this equals 3 plus p. So let me write down this equation as s negative p, and this equals 3 minus 2 is 1. So I'm going to take this equation and write down below this equation. So this is s minus p equals 1. So now we have a set of two equations and two variables, which we can solve either by substitution or elimination method. So I'm going to use the substitution method. So here I find s equals 1 plus p. And now I substitute this s equal to 1 plus p into the first equation. So therefore it becomes 3 times of s, which is 3 times of 1 plus p, minus 2p, and this equals 3. So let's distribute the 3. It becomes 3 plus 3p minus 2p, and this equals 3. So 3p minus 2p is 2p, and when you subtract 3, this becomes 0. So this implies p equals 0. So we found the value of p equals 0, which we substitute into the expression for s, so that we determine the value of s. So therefore s equals 1 plus 0 is 1. So we determine the value of s and p using the two coordinates x and y. Now let's see if this is consistent with the z equation. So I'm going to substitute s equal to 1 and p equal to 0 in both the equations and determine if it is consistent. So let me substitute in z of L1, and therefore this becomes z equals negative 1, negative, s is 1, so it becomes z equals negative 2. And when I substitute in z equation of L3, this becomes z equals negative 2, negative 5 times of p is 0. So therefore this becomes negative 2. Clearly we see that negative 2 and negative 2, that is z is negative 2 when we replace the values of s and p, which means it is consistent. So we can use these values of s and p and substitute in x coordinate and y coordinate in either in line 2 equations or the parametric equations of line 3. So I'm going to substitute in line 2 equation, that is we have x equals negative 1 plus 6s, that is 6 times of s is 1. So this becomes negative 1 plus 6, which is equal to positive 5. So we determine the value of x equal to positive 5. Now let's find y. So we can substitute in line 2 equation, that is into this equation. So I'm going to substitute s equal to 1. So therefore this becomes 2 plus 1 is 3. So we determine the value of y coordinate as well. Now let's put this in the point or the intersection point form. So therefore the point B, which is x comma y comma z, is x is 5, and this is 5, y is 3, and z we already determined as negative 2. So 5 comma 3 comma minus 2 is the intersection point B. So here I have marked the vertex P as 5 comma 3 comma negative 2. Now let's see how to find this intersection point C. This is basically the intersection between the lines L1 and L3. So first let me write the uh, parametric equation of line 1, that is x equals 1 plus 2t. So this is x equals 1 plus 2t, and y equals, this is we are finding intersection point C. So y equals 2 plus 0t, which is we can say just 2, and z equals 3 plus 4t. So this is for line 1. Now let's write the parametric, which is we already have the parametric equation for line 3. So I can write down here, that is x equals 5 plus 4p, and y equals 3 plus p, z equals negative 2, negative 5p. So I'm now going to equate the x equations. So we will get 1 plus 2t. This equals 5 plus 4p. Let me write down this as equation in t and p. That is, I bring the 4p to the left side. So therefore, this becomes 2t minus 4p. And this equals 5 minus 1 is 4. This could be written in simplified form as t minus 2p, and this equals 2 when I divide all the terms by 2. Now we see that the y equation here, it is 2, and therefore this equals 3 plus p. So we write down 2 equals 3 plus p, and so this is 2 equals 3 plus p. From this, we can determine the value of p, and this equals p equals 2 minus 3, which is negative 1. So we determine the value of p. We can substitute into this equation. So to determine the value of t, so therefore this becomes t minus of 2 times of p is negative 1, and this equals 2. So this is t plus 2 equals 2, and therefore we say that t equals 0. So we found the value of t as well as p. We will substitute in both equations of z to determine that these two values, that is t and p, are consistent. So when I substitute in z of line 1, I get z equals 3 plus 4 times of t, which is 0, and this equals 3. And when I substitute p equals negative 1 in the z of line 3 equation, we get z equals negative 2 minus 5 times of p is negative 1. So therefore this becomes minus 2 plus 5, and this gives 3. So these two values of z are consistent, which means the values of t and p are correct. Now we can utilize this value of either t or p, substitute in the coordinates. So I'm going to substitute into the x coordinate of L1. So therefore x equals, into this equation, 1 plus 2t, that is 1 plus 2 times of 0, and this gives x equals 1. And similarly I can substitute in y, but y is already 2, so we see that y equals 2, and x equal to 1, and therefore the intersection point C, we can write down this as C is x comma y comma z. X is 1, y is 2, and z is 3. So therefore this is the intersection point C. So now that we have determined all the intersection points, we can determine the side lengths. So first we will determine the side length AB, and this is the distance between the points A and B. So we can utilize the distance formula. That is AB, this equals under the root of x2 minus x1, that is 5 minus of minus 1. So therefore this becomes 5 minus of minus 1 quantity square plus y2 minus y1 quantity square, that is 3 minus 2 quantity square, plus z2 minus z1, that is minus 2 minus of minus 1 quantity square. Let's evaluate this. This is 5 plus 1 is 6. So this is 6 square, and 3 minus 2 is 1, 1 square, and this is negative 2 plus 1 is negative 1 quantity square. So therefore this gives 6 squared is 36, 1 square is 1, and negative 1 square is positive 1. So therefore this equals under the root 38. So the distance AB, that is the side length AB, equals under the root 38. So I can mark under the root 38 here. Now let's determine the side length BC. So here we have to consider the BC equals x2 minus x1. I consider this B as x2, y2, and z2, and C as x1, y1, z1. So therefore, this becomes a 5 minus 1 quantity square. So it is 5 minus 1 quantity square plus 3 minus 2 quantity square plus negative 2, negative 3 quantity square under the root. So this equals 5 minus 1 is 4 square plus 3 minus 2 is 1 square, and minus 2 minus 3 is negative 5 quantity square. So this becomes 4 square is 16 plus 1 plus 25, and this equals 16 plus 1 is 17, and 17 plus 25 is 42. So this is equal to root 42. So I mark root 42 for the side length BC. Now let's determine the side length AC. So AC is the distance between the points A and C. So I consider A point as x1, y1, z1, and C point as x2, y2, z2. So therefore AC, the distance AC is 1 minus of minus 1, that is 1 minus minus 1 quantity square plus 2 minus 2 quantity square plus 3 minus of minus 1 quantity square under the root. So this is under the root. So therefore this becomes 1 plus 1. This is 2 square plus 2 minus 2 is 0. 0 square is 0. And this is 3 plus 1, 4 square. So therefore this becomes 2 square is 4 and 4 square is 16. So we get root 20. So I mark root 20 for the side length AC. So now we can calculate the perimeter of the triangle since we have determined all the side lengths. So therefore we say that the perimeter of the triangle ABC, this equals AB plus the side length BC plus the side length AC. So we substitute AB, which is under the root 38, plus BC is under the root 42, plus AC is under the root 20. We plug this into the calculator and we approximately get the value as 17.12. So this is the perimeter of the triangle.